Okay, so we're going to talk about co-function identities here. Notice that I've arbitrarily labeled an angle as alpha, and I've labeled the other angle as pi over 2 minus alpha. Let's make sure we understand why it's pi over 2 minus alpha. Well, think about a full triangle has 180 degrees in it. 180 degrees is the same as pi radians, but we have a 90-degree angle right here, that right angle there. 90 degrees is equivalent to pi over 2. So, whatever this angle is, these two combined have to equal pi over 2, have to equal pi over 2, because together, all three of those angles have to equal pi. So we have pi over 2 plus alpha plus pi over 2 minus alpha. That should equal pi. Does it? Well, plus alpha minus alpha, pi over 2 plus pi over 2 equals pi. So we're good. That's why that labeling makes sense. That's why we choose to label it that way, because it's a little more generally applicable to many different functions. So now let's get into it, and let's think about what's going on. So think about the sine of alpha. Sine of alpha, sine is opposite over adjacent. The opposite side from alpha is A. The adjacent side from alpha is B. So sine of alpha is A over B. Compare that then to the cosine of pi over 2 minus alpha. And again, pi over 2 minus alpha, all that's saying is the other angle in this right triangle. Well, the cosine of this angle is going to be adjacent, which is A, over hypotenuse, which is C. So notice that I goofed this up from the very beginning. I said sine was A over B. That doesn't make sense, because sine is opposite over hypotenuse. The opposite side from alpha is A, the hypotenuse is C. Sorry about that, I don't know what I was doing. But notice, sine of alpha is A over C, cosine of pi over 2 minus alpha is A over C, therefore sine of alpha equals cosine of pi over 2 minus alpha. That's kind of neat and cool. Let's see if some more relationships like that exist. Yeah, they're gonna. How about secant? Let's say secant of alpha. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So secant of alpha is going to equal the hypotenuse, C, over the adjacent side from alpha, that's B. So secant of alpha is C over B. Well, what about cosecant of the other angle, pi over 2 minus alpha? Well, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over the opposite side. Hypotenuse is C, and the opposite side from pi over 2 minus alpha is B. So again, they're both equal to C over B, which means they're equal to each other. Secant of alpha equals cosecant of pi over 2 minus alpha. And then finally, the last relationship, tan of alpha. Tan is opposite over adjacent, so from the angle alpha, the opposite is A, the adjacent is B. So now we get our A over B for tan. Compare that to cotan of the other angle, pi over 2 minus alpha. Cotan, if tan is opposite over adjacent, cotan is adjacent over opposite. The adjacent side from pi over 2 minus alpha is A. And the opposite side from pi over 2 minus alpha is B. So again, they equal each other, so they are equivalent. And so we have our co-function identities. Sine of alpha equals cosine of pi over 2 minus alpha. Secant of alpha equals cosecant of pi over 2 minus alpha. And tan of alpha equals cotan of pi over 2 minus alpha. That's why they are called co-functions, because they complement each other, kind of like complementary functions, because two complements mean the two angles add up to pi over 2, or 90 degrees. So think about that. Think about if we have this little, what am I saying, this little quadrant right here. Well, imagine if, try a little bit bigger. Imagine this quadrant is what we have. Well, imagine that full quadrant is pi over 2, because that's the same as 90 degrees. Well, if I split that up, and if I were to subtract away that pi over 3, well, how many pi over 3s would be left? 2 of them. And that's equivalent. Oh, I wrote that wrong. That should be pi over 6 if I'm drawing that 30-degree angle. If I subtract pi over 6, what's left? Well, 2 pi over 6, which is pi over 3. If I subtract that pi over 3 chunk, then what would be left? Well, pi over 6 would be left. The angles complement. That's when we end up with these co-functions. That's why sine of pi over 6, which is 1/2, that's why that equals the cosine of pi over 3, also 1/2. Again, thinking about on the unit circle. The sine of that value right there is equal to the cosine of that value. They are complementary angles, and the complementary functions are equivalent. Similarly, could do the same thing, but with splitting this pi over 2 in half to pi over 4. Well, then what's left? It's another pi over 4. And that's why sine of pi over 4 equals cosine of pi. That's not pi. Pi over 4. That special point right there where the two values are the same. They're both root 2 over 2. That's why that's happening, because of this idea of complementary functions. Now, there was a typo on your study guide. Your study guide probably says alpha minus pi over 2. And, well, I goofed up in writing that, but think about how that would connect. Alpha minus pi over 2 is the opposite of pi over 2 minus alpha. Think about factoring out the negative. Pull that negative out front, and we're left with a positive pi over 2, and then the alpha becomes negative. So, pi over 2 minus alpha and alpha minus pi over 2 are opposites. And if you wanted to, you could then think about even and odd functions, and you could come up with some new relationships there using pi over 2 minus alpha instead of alpha minus pi over 2. But I'm not going to do that now.